So to get information about the package, you can just look it up, something like this. We want to get information on psych package. And when I type psych package R, takes the first one that usually comes up is the CRAN website. CRAN is the website where the R program is housed, and a lot of packages that are developed for R are also provided through this website. So if you click on it, it gives you information about this package, what it does, a general summary of it, and you have several PDF files that you can access here. Reference manual, if you click on it, it will show you what all of the functions are, and you can read about them and how to use them. But that's a lot of information. If you want quick information on specific tasks or some introduction to the package, they usually provide what they call vignettes, and a lot of packages have these. So in the vignettes, for example, this one says introduction to the psych package. You click on that, and vignettes are usually written in simple language, and they start with very basic stuff like how to load them and how to read your file into them and so on. And they give you actual code that you can copy and paste and modify and make sure that your package works. And that's a good practice for using any package. Before using it on your data, it's a good idea to use it on the example data that they provide. Then you know that it's working, and then you can load your actual data and use the package on that.
And Hamid, when you upload the sample data, that's data that the package comes with already?
Yes. A lot of packages have sample data usually coming with them, and R itself has some sample data. For example, one of the sample data that I mentioned last time is called empty cars. So, for example, if I type empty cars, it pops up a bunch of information about cars, different models and stuff. Or if I type iris, it has information about different species of irises with interesting data like sepal length, sepal width, and species, setosa, versicolor, virginica, and so on. So these are usually, there's a lot of example data that you can work with. Sometimes the package itself comes with it, but sometimes you can just use one of these universal sample data. Any questions, comments so far?
Yeah, so if we want to like run this sample data, do we have to load this library at first?
Iris and empty cars, they're available on all our versions. So you don't have to load any package to use them. But some packages have specific data that are designed for being used with that specific package. And for that, you have to load the package. For example, you type library psych and run that. And then all of the sample data should be available once you load it. And there's the psych tools that you can also see. Let's see if we can. That this says it's not available, so I have to install it separately. But let's see if this one will run. No, because it needs psych tools. Anyways, but either you use the data with the package itself, the one that comes with the package, or you can use one of these example data to play with. You might hear my cat yelling at me. What is it? What do you want?
He's hungry.
I just fed him. He wants
What's
playtime.
more?
Julie, they're talking about you here.
Can you show us your cat if that's...
You want to be on the Zoom call? He doesn't seem interested, sorry. Anyways, you can just hear him in the background. So I'll go over, do you guys have any questions so far? All set. Okay, I'll go over what we covered last week real quick. And as I do that, you can make sure that you load all of the phenotypic data that we were working with last time. And I think I gave you the script. Or if I didn't, I can send it to you last week. Let's see if I gave you the script. Okay, looks like I didn't give you the script. I'll send it to you here. In the same folder where the videos are, you can find the script as well for session 4. This is the session we're in. But I'll go over the codes that we covered. One of the most important ones is to setting the working directory. Control Shift H on Windows, and I don't know what that is in Mac. Is it Command Shift H probably? And gives you an option for setting the working directory, or you can do it here under Session, Set Working Directory, Choose Directory. So those are the ways you could do it, or you can just type this set working directory with the address to where your files are. After you set your working directory, everything that you load has to be present under that directory. And all of the output from your analyses are going to be also saved there. The second thing we learned was to create objects. So in R, we have several different categories of things. The first one, the obvious one, is called a package. And these are add-ons that you can install and add it to your RStudio. And each package has something called functions in it. So all of the methods and all the functionalities of each package are within functions. And one of the functions we learned about is called plot, which we can use for creating plots. And each function is usually written just with the name and parentheses. And to quickly know what the function does, we can add a question mark. And if we run it, then help pops up on this side of the page. A lot of interesting information as well as examples. And these are the examples that we can use with this package. For example, here it says require stats. Stats is another example data that you can use, or plot cars and so on. We learned about how to plot things. I'll do a quick demo with cars. This shows just the speed of the car and the distance. Like the faster it goes, the longer distance it goes. It's silly, but the other thing that this package, the other thing that you can do is LOS. LOS is a function that allows you to draw a line through data. kind of like summarizing the pattern that you see. For example, here you see a pattern, and you want to see what the minimum distance between these dots and the average is. So you can do LOS by just using the example line. So you just type lines, LOS cars, and then it kind of summarizes the trend for you with a line. It helps you visualize things. And LOS, and there's so many other ways to make lines, and maybe some of them are a little more smooth. So you might come across this in your analyses at some point. So that's a way to get help. We learned about how to load CSVs, how to change column names. And if you just type column names, locations, for example, it will just give you the names of the columns. And if you want to change it, you can say the first one, I want to be accession numbers. This was already accession number, but there were some hidden characters there that were causing issues. So we just fixed it by typing the name again. We learned about how to look at the top parts of data with head function. These are the same things, just doing the same thing on different data sets that we had, leaves and flowers and fruits. We learned about how to delete a column. In this case, we're deleting the researcher name column in both of the files. Then we learned about how to merge files by a specific column. In this case, we want to merge all of the data by accession number. And again here, so first we merged leaves and flowers and locations, and then we merged fruits by that temporary file that is the combined version of locations, leaves, and flowers. So we ended up with a file that says all data with locations. So it has both locations, fruit data, and leaves data. And then we learned how to use the psych data, the psych package. If we load it and do pairs panels, it gives us these cool graphics. This is too many. Maybe I could just do 6 so that we can see. It gives you nice plots, distributions, as well as the R-squared values. And the other one that we used for correlation is called core plot. We had some trouble with this one using it on R data. In the last session, I talked about how we can use this with the cars example data, but this time I figured out how to use this on R data. So 2 libraries that you need to install is CorePlot and R Color Brewer. We installed them both last time, so we should be able to easily load them. And then one problem we had was that when you do correlation analyses, and sometimes you have missing data, that causes an error. And to avoid that, you say use complete observations, meaning that if there is missing data, ignore it. And here I'm saying I want these columns, 19, 26, 27, and 28. So 4 columns, which are all fruit data. And if I do a correlation analysis, the results will be saved in this object M. So it just shows you a table with all the R-squared values. And it's just pairwise fruit weight, fruit length, fruit width, and carpel number. And if you want to make a nice plot, then you use core plot. M type is upper, the way that it draws the figure, as well as some other things, as well as the colors, etc. And if you run this, you'll see a plot like this, pairwise correlation, and it will help you quickly find out which ones are correlated the most with each other. Of course, you're gonna see the biggest correlation between everything and itself, like fruit length and fruit length. So it's just artifact, but the biggest thing that we're noticing here is fruit weight and fruit width, which is highly correlated. And the color tells you how strong the correlation is, whether it's a positive correlation, which is blue, or negative correlation, which is red. And it's interesting to know that fruit weight and carpal number also seems to be highly correlated, which is the case also in tomato. So one of the major things that people discovered about fruit weight in tomato is that genes that are involved in locule number development. And so you know that fruit weight is a very economically valuable feature. So if you discover a gene that controls fruit weight in eggplant, that will be super cool. So, and similar case, like I said, we see between eggplant and tomato in correlation between carpal number and fruit weight. Any questions so far? All good? Okay, we can continue. I'll quickly look at my notes. So psych package, merge. So we learned how to merge two different data sets that share a column. But there are ways we can merge things that have the same row numbers or row names, but different columns. And we can make test data just to play with. For example, we can call it test 1 is data frame A equals 1 to 5, B equals 4 to 8, and C equals 5 to 9. So now we have a test data. And if I open it, it shows me a file with 3 columns A, B, C, and some numbers. And it has 5 rows. To quickly duplicate this, I can type test2 equals test1. So that's a way to quickly duplicate it, but I want to make another data frame with different columns. D, E, F, and then maybe I'll call this 2 to 6, 5 to 9, and 6 to 10. So now I have 2 files, which we call data frames. And they look like this. The first one has A, B, and C. And the second one has D, E, and F. So there are 2 ways that two ways that you can merge things. One is by column, one is by row. The one for column is called cbind, the function. So if I type cbind test1 and test2, let's see what's gonna happen. So it combines the 2, and now we have a new data frame with 6 columns. A, B, C, D, E, F. Okay. And if you want to save it, you can just call it combined columns equals that. If you run this now, and you'll have a new object called combined columns that you can open and see the, or you can save it with write.table. The second way to merge things, sometimes you want to merge them the other way by rows, and that's called rbind. So cbind is short for column bind, and rbind is short for row bind. And test 1 and test 2, if we do this, it probably won't work. Let's see. Yeah, it says that the columns don't match between test 1 and test 2. That for this to work, if you're combining two things, you have to make sure that all column names are the same, and you just want to combine the rows. You can combine test 1 with itself, and it just, what it does is, so you have 5 rows here, and the next 5 rows are just duplication of these. So the same are being duplicated. 1 to 5 are the same as 6 to 10. But you can also make another file, another data frame called test3, and make sure that the column names are the same as in test 1. Give it different numbers. And run that. Now you have a different data frame, and you can combine test 1 and test 3, making sure that the column names are the same. One quick way to test is column names, test 1, test 3. And you immediately see that they're identical for the column names. That's a test you can quickly run, or you can do this. You get these values true, true, true. So double equal sign is used for comparison. Single equal is used when you're assigning a value. So they are very different in function. You have to be careful. So you can test, and it says that the column names are matching. And then you can combine. You can say combined rows equals rbind test 1 and test 3. If you run that, then you have a new data frame that has those. Any questions about merging? So we learned 3 ways to merge things. One is merging by shared column that we talked about last time, or merging when the rows are the row numbers are the same, but the columns are different. That we use column bind or cbind, and we learned about how we can merge things when they have identical column names with row bind, which is rbind. Any questions? All good? Cool. So subsetting is the next thing. We can do this both with example data that we created here, as well as our actual data. So subsetting is done with brackets in R. So we have here a file called combined rows, and you type brackets, and then if you type a comma in the middle, you can give it two numbers. One, the first one before comma, is the row number, and the second one is the column number. So in this case, I'm saying I want to see the first column and the first row. So I want to see this number, which is the first column and the first row. And if I run that, then it shows me that value. If I say the first row, second column, it's 4. First row, second column, and so on. If you don't type anything for the first number, that means you want to see all the rows. If you type something like this, that means that you want to see all of the rows for the first column. So you see all of these numbers for the first column: 1, 2, 3, 4, 5, then 3, 4, 5, 6, 7. The same is true for rows. If you want to just see the first row, all the columns, it will give you something like this: ABC 1, 1, 4, 5, same as here. There are ways also to see specific columns or specific rows. For example, you can say combine columns. I want to see the second and third. You can write 2 to 3, or you can write, if it's not in a sequence like 2 and 3, you can, if you want to see 1 and 3, you can do with C. C parentheses 1, 3. So in this case, I'm saying I just want to see column 1 and 3. And if I run that, it's just showing me A and C. So what I just did was making a vector. So vector, C is short for combine. So if I write something like that, I'm making a little object that has 1 and 3 in it. Or you can do it this way: 1, 3, 4. It's showing 1, 3 to 4. You can do 1, 3 to 10, and it's giving me the first numbers 1, 3, all the way to 10. So these are all vectors, which have a series of numbers in them. So, and that can be used for selecting specific columns that you're interested in. No. The other way to select a specific column, you can just give it the column names. I want to, for example, just see column A and column B. You just type the name of the column in dash if you want to see it. And if you want to just see a single column, you can use the dollar value, dollars, A, B, C, D, and it gives you an option to select which column you want to see, and that's how you do it. So there are multiple ways to do subsetting. There are ways to subset based on a range. You want to say, for example, I want to see all the rows where the column A is bigger than 2. And you can do that, and I'll discuss that in a second. But Do you all have any questions so far?
Ahmed, I'm getting a weird error here when I try to look at just some specific columns.
Okay, let me stop sharing so that you can share. Just 1 second. My cat is distracting me, sorry. Okay, go ahead.
So I put a data set, I called it just combined rows. And then I have my brackets, and then I put C for columns, and then to look at say columns 2 and 4.
C, sorry, C is not for columns, C is for combined. It's all confusing, but it has a different meaning. Okay.
So what should I put here instead?
So it's correct, but the definition of that C that you put there, what you're saying is that you want a vector combining 2 and 4. In other words, you want columns 2 and 4.
So
that looks correct. The problem might be that maybe combined rows don't have 4 columns.
Oh no, that's right. It doesn't.
Yeah.
It's
Could
only
do,
it's
yeah,
only 3 columns.
right. You could do 2 and 3, or one and 3 if you want to do.
Yeah, combined combined rows is only ABC. Okay.
Right. Right.
That was a little bit silly.
That's fine.
Okay.
Cool. Any other questions? So I want to quickly explain that vector thing again. So let's say you want to create a vector of 1 to 1000. You just say A equals 1 to 1000. And if you type A again, gives you what we call a vector with a bunch of numbers in it, 1 to 1000. The other way to do this is to do A equals C, and C is usually used for when it's not a range. You're trying to get just specific numbers in there. 1, 3, 8, 10. So you type it like this with C parentheses and then just individual numbers. And now if you type A, it shows you all the numbers that you just typed. So that's just creating a vector. And here we used it to just select columns 1 and 3. You can also use it for rows. Let's say I want to just see row 1 and 3 and all the columns. I can do it like that too. And now it's showing all of the columns, but only row 1 and row 3. Okay. So let's complicate this a little bit. Another subsetting thing that you might find very useful is based on values. For example, you want to select the rows where the value of A is greater than 3. So any value that any of the entries where the first column is smaller than 3 will be removed. So we'll do it like this. Combined columns, brackets, where combined columns $A is greater than 3. And then we type a comma and empty space just to, actually it doesn't matter if you type space or not, but just leave it empty here after comma, meaning that we want to see all the rows. sorry, all the columns. So the one after comma is all the columns. But we want to see all the cases where the first column is greater than 3. And if you run this, just quickly finds where A starts being greater than 3 and just showing those. Okay. Of course, you can do this row-wise. If you want to say, I want the second, if the second row is greater than, like if you want to say, I want to find cases where the second row is greater than 2. You can type it like this, but then comma should be on this side. So you want to see all the rows where, or sorry, wait. I want to see all the columns where second row is greater than 2. And this should be this way. I think I made a mistake there. So you want to see all the rows where the second row is greater than 2. And that's how it is. So in this first one, we were just trying to find where the first column is greater than 3. And in this one, we were trying to find all cases where the second row is greater than 2. And that's what we're getting. Any questions?
Well,
So, yeah,
when would you use this if you just like have a bunch of data and you're just trying
right.
to find certain data sets kind of thing?
Great that you just segued into my next section when we can use this in real life. So we have a file called all data with locations, and it has a bunch of columns and rows. If you want to quickly see what column names we have, you just type column names, that, and it gives you column names, actual names, and a number next to it. So if you want to make a subset, let's say if you want just these 3, you can do this. All data with locations, and you want just see columns 1 to 3. If you type this like this, it will just give you the first 3 columns, but it will output it like this. But if you want to actually save it into an object, you can give it a name, say first 3 columns. So, and then you have a file here, an object here that you can open. And it's just showing the accession number, species, and country of origin, the first 3 columns. Of course, if you do this, if you put the comma on the other side, it will give you the first 3 rows. So that's how you would change it. If you just want to save the first 3 rows, you do it this way, and it pops up here. And now it has the first 3 rows for these 3 accessions for everything. That's one. One task that you probably will come across a lot is to find data for specific species. For example, if you're just trying to limit the data set to just Melongena. So you can type Melongena. Your task is to create a subset of the files. So you want to ignore all of Insanums and Ovigerums, and you just want to see Melongena. Then you can do it this way. Melongena equals all data with locations, where all data with locations, again, $species equals Melongena. And don't forget to type the comma, because you want to see all the rows. Sorry, all the columns. So if you type it like this, it pops up it spits out the information for everything that is Melongena. You can save it into Melongena, and then you can open it. And now you should have data for just one species. And of course, you can do this for Ovigerum. By copying and pasting and then changing the values. Now you have Ovigerum. There are some weird NAs here that we need to get rid of, but for now we can see that these are all Ovigerum. And the third one will be Insanum. So here are the values. Now that we were able to subset our data into species, we can make comparisons. For example, if you want to compare the fruit weight in Melongena versus Ovigerum, you can do a histogram like this. Histogram Melongena $fruit weight. That gives you a range. If you want to find the mean of the fruit weight in Melongena, type it like that. It says mean is NA. Because this one has missing data, it doesn't give you a value, so you can add an option called NARM equals true. That means that we want to get rid of the missing ones so that we can get an average, and gives you the mean for Melongena fruit weight. And then you can, if you want to just quickly compare with the other things, you can do a histogram for Insanum fruit weight, gives you a plot, and then here also. So the average fruit weight in Insanum is 9 grams, and the average fruit weight in Melongena is 186. The other thing that I want to mention is the difference between mean and median. In statistical analyses, when you're comparing two groups, it's often common to use median instead of mean, because mean can be affected by outliers. For example, if you have a lot of small fruits, and then one fruit is just super big, it can affect the average. But median is not affected usually by the outliers. So if you want to compare the mean and median of fruit weight for these two species, Melongena and Insanum, you can do that. It's the same structure. Instead of mean, you just type median. So the mean fruit weight was 186, but the median is 170 for Melongena, and for Insanum, median fruit weight is 9.75. So there's not much difference between medians of fruit weight in Insanum. So mean and median are very close, but in Melongena we see a difference. Okay, so any questions so far?
Quick question, Hamid.
Yeah.
I was looking at some of the histograms when I think you explained it.
Right.
But the values you have in terms of the median and mean command, NARM equals true.
Right.
What was that? What was the purpose for that? One more time.
NARM.
Mm-hmm.
NARM means if there is a missing value, don't include it.
Okay, perfect.
Yeah. Whenever you have missing data and you want to get the average or do other things, it gives you an error. So you're telling the program that you don't want the missing data to be included in the calculations.
Okay.
So we have only 4 minutes left. It's a good place to stop. In the next section, I'll teach you how to plot phenotypes based on groups. So a while back we did a plot where there were values, the distribution of values for fruit weight, for Insanum, Ovigerum, and Melongena. So there were 3 bar plots with the distribution as well as medians and whiskers. And in the next section, I'll explain all of that. And we can learn about how to do statistical analyses when we want to see one group is different from another group. So we can do that next section, in the next session. Any questions?
No, all's good.
Sounds
Okay.
good.
Thank